Okay, chapter 17, DC circuits. First, we'll look at what is a series circuit. For a series circuit, the components are placed side by side to each other. So you have a battery, we have a component like a resistor or bulb, and we have two of them, R1 and R2. They are placed side by side to each other. So it's said to be a series circuit. For series circuit, the current is the same throughout. So current, it goes through all the components, is the same. Next, what we have is the voltage. Whereas this time, the voltage is a summation. So the EMF of the battery will output the potential difference of resistor 1 and resistor 2. Okay, now let's move on to the parallel circuit. So in a parallel circuit, can we draw it? A battery, one component or resistor, and another resistor or component. So this time round, the voltage, the PD, is going to be the same. The EMF is going to be the same as the potential difference of the first resistor and the potential difference of the second resistor. So now the difference is the current. So current 1 will split into current 2, current 3. And after that, they will merge back to current 4. So you see that I1 is equal to I2 plus I3, which is the same as I4 when both current merges back. So how do you calculate the resistance, total resistance of a parallel circuit? The formula is given by R1 over RT equals to 1 over R1 plus 1 over R2 plus 1 over Rn. Whereas for a series circuit, the total resistance is calculated by RT equals to R1 plus R2 and Rn. Okay, now let's move on to the next part. Potential difference. What is a potential difference? It's a line of resistors connected in series, okay, to provide a fraction of the voltage to the source or another part of the circuit. And that is for something like a fan, or even you want to control a light bulb or a spotlight, and control the intensity of the light bulb or spotlight. Okay, so there's actually two components, one here and one with an arrow. This is a variable resistor. Just the rectangle block is a resistor. Okay, so how do we get the current? We use Ohm's law. R equals to V over I. I is equals to V over R. You get R total. We mentioned before, in a series circuit, for series, R total is just R1 plus R2. So you will get V over R1 plus R2. And we also mentioned in a series circuit, the voltage is an addition of each other. So the total voltage or the EMF is V1 plus V2. So you can substitute here in here. So you get V1 plus V2, R1 plus R2. Since the current in the series circuit is always constant, so it's going to be the same throughout. Look here, I is going to be the same. Okay, and with this, you can rearrange the equation to get your output, either V2 here or V1. Can rearrange them. In this case, the V2 is the voltage output. Okay, so next, we can look at the variable potential difference. With this, we can actually change two fixed resistors and make use of variable resistors. So something like this. We can add a variable resistor in the circuit. Two types of variable resistor. One is variable resistor plus a normal resistor. Another one is like a potential divider. Okay, so first, type 1, rheostat. Okay, so for rheostat, it's a variable resistor connected at the two terminals. Same formula as before. We have derived this formula. Okay. So when I were to increase the resistance of R1, okay, which means that actually the voltage 1 will increase, resulting in, since R2 is constant, voltage 2 here will decrease. Okay, so vice versa. Next, let's look at a potentiometer. You can see that the design is slightly different. You only have one component for potentiometer versus a rheostat. So rheostat, you have two components. One here, a variable resistor. One with a fixed resistor. Potentiometer, just one block with a slider contact. So there's a slider contact here. Okay, this slider can move up and down. Can be moved up or it can move down also. Remember in the previous topic, R equals to rho L over A. We talk about the resistance of a wire. If I were to increase the length, the resistance of the wire increases. Okay, so in this case, if I were to slide my slider, okay, and make sure that the length of the wire, you can see the slider C here. If slider C goes all the way to the end, you realize that now the current has to go through more wires, length increases, resistance increases. Okay, so this is one other way to change the resistance of a component. Okay, so this is actually the derivation of the current, the same as the previous calculation. Okay, next, what are transducers? Okay, so transducers are electronic devices, okay, that converts energy from one form to another. It can be from electrical to non-electrical or non-electrical to electrical. That's why there is input and output. So for input transducers, okay, we use non-electrical to electrical, which is what your syllabus wants the focus on. Then the output is the opposite, where we convert electrical to non-electrical. These are some of the examples here. Okay, so let's dive into the input transistors. Input transducers. And the first one is a thermistor. Okay, so for thermistors, there's two types. there is a NTC, which is a negative temperature coefficient, and there's a PTC. Okay, so they are slightly different. For NTC, which is the circuit shown on the right, when you increase the resistance, the voltage decreases. Okay. So vice versa. So if the resistance decreases, resistance of the thermistor decreases, the voltage from the thermistor increases. That's why it's called negative temperature coefficient. For positive temperature coefficient, when the resistance increases, the voltage increases. What's the use of a thermistor? Okay, it's used for temperature control as well as measurements. When the temperature changes, the resistance of the resistor changes, and then you can output, like for example, your aircon or your fan, you can increase the voltage to your aircon or your fan to cool or to heat up the room accordingly. Next, we look at the input transistors for LDR, which is light-dependent resistors. So like the name suggests, for the word thermistor, is temperature dependent. LDR, light. Okay, visible light. Okay, so for LDR, the resistance, okay, decreases when the light intensity increases. When the light intensity increases, the resistance decreases. And because the resistance here decreases, the voltage of the LDR actually decreases, causing the other resistors here, since the doesn't change, the voltage increases for this component. Okay, so you must remember the voltage is being shared. If the voltage here on the top here increases, means the voltage of this resistor decreases. Why? Because in a series circuit, let's go back, series circuit, the voltage is addition. EMF, voltage of your LDR, plus your voltage of the resistor. So if one increases, the other one needs to decrease. Okay. And that's all for today's lesson.